distance measured between either quantum particles or planetoids is a measured distance between the frameworks, so they stay the same. The only difference would be the actual constant. So gravitational constant would become the electric constant K, or Coulomb's constant. And the formula at the bottom was what I developed within this framework. And the following slide will show you an interesting relationship based within this framework. Okay, so take into account that M1 and M2 are the same as Q1 and Q2. Eliminate them. They're the same thing. So you're left with basically just the constants, KD and gravitational constant, and the framework that it's being wrapped in as. So the scaling framework, which is the stuff in red and green there. And what I found interesting is that without even knowing what the velocity I'm traveling at, or the initial velocities of the network, or of the example here, I derived 5.98 times 10 to the power of 23, based solely on this relationship. And that number is 99% that of Avogadro's constant, 6.022 times 10 to the positive 23. So I found that I didn't expect. I had to put that slide in because that blew me away. I have no idea what it means, but it's fascinating. And
sorry.
Yeah, no, go ahead. That's fine. Which leads me to the next question, because if you haven't thought about it yet, it's very important. What is the quantum invariant mass of quantum particles? I've talked about mass at the celestial scale becoming charge. Well, that doesn't explain, how a charged particle still has mass, right? And there is a significant reason why. The Thomson experiment is a famous experiment that derives the ratio between mass and charge. And that ratio is based on a force comparison between electric force and gravitational force. And that force value, the difference in electric force to gravitational force, is roughly 2.9 times 10 to the power of 39. So if I plug this in as the derived value of the difference between these two forces, I get a velocity, an initial velocity. Sorry, a final velocity of 3.76 times 10 to the power of 8 meters per second, which is faster than the speed of light. At the same time, you also consider that velocity is the net kinetic energy velocity of the rotation and linear of the object being accelerated. It's also derived from the initial velocity being equal to 1. So by being able to derive this value, this difference in force strength, you can derive the mass of a proton and electron according to modern science. So next screen. Which is that? A proton is 1.67 times 10 to the negative 27 kilograms, and the electron is 9.1 times 10 to the negative 31 kilograms. So, and this is just strictly based on force comparison between the two. Next screen. I'm reaching the end of my presentation. There are implications and predictions in this framework. There's a lot of predictions. For example, the universe is infinite in size. That's an assumption I made, which has further far-reaching implications in regards to probability theory. Star systems have much longer lives than previously estimated. For example, that example I mentioned about 1 second being equal to 9 times 10 to the power of 26 seconds in passage at the quantum scale. Well, that's an enormous amount of time. It's over 4 billion years old, as according to how long our planet's been here in relative comparison. So star systems do live much longer than previously estimated within this framework. Celestial black holes are possibly nothing more than just very large and heavy celestial atomic systems, like the uranium system, that has lots of planetoids circling the core of it. And there's more predictions that I'll leave it for another day, or for you to read up on it. Following screen. This is why I'm here. I was looking for very intelligent people to listen to this, and in order to actually help develop it. Because I have an engineering background, but I'm not a physicist. And I don't have some of the tools that other people have to further develop this theory. I've come across, I think, some interesting results, and they correlate, they map planet's mass to an electron charge. I think that's pretty significant. And a few other coincidences, for example, Avogadro's constant. So the theory might be wrong and might have errors, but I think I'm on something. And I think this is what science is supposed to be going towards. And the conclusion of all this is that special theory of relativity is wrong. There's lots of errors. And I'm not saying general relativity is wrong. I think it's actually more correct than SRT, but it's definitely needs modification. And that's very much it. So if you guys want to do your own research and help, I would appreciate it.
We've got a few minutes for questions, so if you have questions, if you would be so kind, come over here to the mic and ask them. I'll go first and just give you my comment, and that is, first of all, I think that some of these ratios are really quite interesting, and we definitely, like your scale factor, there's a unitless number that I'm interested in exploring and learning some more about. I would say some of the playing with numbers, like the square root of the velocity of light, that are inherently unit driven, I'm not as excited about,
right?
Because you're comparing apples to oranges. For example, Avogadro's number is not a unitless number, although you might think of that. It's actually a number that is in terms of molecules per mole, and a mole is defined as characteristics of standard temperature and pressure, which is arbitrary, consideration of the properties of water and the metric system. So it's not really a number, again, to get, for me at least, to get all that excited about. So but the unitless numbers are definitely, then you got something real, something that's not dependent on the unit system. Anyway.
And we're quite, that's exactly my point. I don't know how Avogadro's number actually plays into this, but deriving that number was interesting.
I'll just say that you stole my question.
Sorry. Okay. We got some time for more.
Yeah. I can't hear you, sorry.
No, maybe electric слабая. Но electric и gravitational
Gravity force and every force of Avogadro?
Speak Russian. Speak Russian. He'll translate.
Я могу по-русски сказать. Гравитация и электрические силы не соединяются никак.
Can you repeat the question? He'll say you repeat it.
Никаких обстоятельств. Значит, электрические силы и слабые взаимодействия соединяются. За это получил Нобелевскую премию. А гравитация и электрические силы не соединяются. Это никому доказать не удалось.
He's saying reality, that there is never relation between gravity and electromagnetism. There are totally different interactions. They have nothing common, and nobody has idea that they should have something common. But this is not true, because if you heavy side, heavy side,
Сейчас скажу, электрические силы.
Вы читали работу Ефименко?
Читал.
Вы читали, но не читали, садитесь. Вы читали, что о чем говорит?
Нет, подожди. Электрические силы обладают притяжением и отталкиванием. Гравитация не может обладать отталкиванием. Не может. Все. И конечно, никакой изменения тут не может.
Вы видите в этом.
We need to reduce the straight question.
I totally agree.
This is common believing that the difference between electromagnetism and gravity is that electrons repel and electron proton attract. So if you have beryllium atom, they mean that Earth and Mars, they should repel. And do you have this?
No, I haven't calculated
Repeat
that.
the question.
So essentially what you're asking is, if you have two planets, like for example, Earth and Venus, being almost the same size.